Greetings! Today, for your viewing pleasure, I have a graphing calculator to show you. One that is really unique and that you're probably not very likely to see in the wild. Now, when it comes to graphing calculators, the first brand that probably comes to everyone's mind, including my own, is Texas Instruments. Texas Instruments is by orders of magnitude the most popular maker of graphing calculators. Given the huge amount of market share that Texas Instruments has with their graphing calculators, other manufacturers of them, such as Casio and Sharp, kind of don't get the praise that they deserve. Casio especially, because they actually invented the graphing calculator back in the early 1980s, if I remember right. Well, the calculator I have to show you today was made by Casio, and it has features that I think trump Texas Instruments in terms of usability and user-friendliness and such. So here it is right here. This is a Casio CFX-9850GB Plus. This is a graphing calculator made in 2002. Now, when it comes to scientific calculators, I am definitely partial to Casio. They are my go-to brand. And after owning this calculator for a good few months now, I'd say close to a year maybe, they are definitely going to be my go-to brand for graphing calculators. Now, what's probably the most unique feature of this graphing calculator, if you might be able to see written below the screen there, this calculator has a color LCD display. A very interesting and unique color LCD display, which I'll show you later. Now, the Casio CFX-9850G series began in 1996 with the 9850G. Then they replaced that with the CFX-9850GA Plus, then the 9850GB Plus, and then the last model in the series was the CFX-9850GC Plus, which was discontinued in 2008. Now, all the models except for the GC Plus come in this case design, but the GC Plus does come in a more modern style case design. Basically, the successive models fixed bugs and other issues with the first model. This model, the GB Plus, actually comes with its own software library, which I'll show you in this video. And then the GC Plus, while it didn't have the software library, it did come with 64 kilobytes of memory. All the previous models, such as this one, come with 32 kilobytes. So these calculators retailed for around $50 to $60 new. They were cheaper than the Texas Instruments models. And like I said before, this calculator has some features that the Texas Instruments calculators do not have that I think are pretty good to have. And the overall way you use it is, I think, better than the Texas Instruments way. And between that and these being cheaper than the TI units, I honestly would choose this if I was given the choice between one of these and a Texas Instruments calculator. With that being said, the TI units do have some advantages over these, which I'll go over in this video. But for now, let's take a look at it here. So you've already seen this here. All the buttons. Standard graphing calculator buttons. Somebody scratched out what looks like 2002 there, so I would think that would be the year this was made. So I often wonder if this was a school calculator, if this was deployed in a high school, and they wrote the year on it for some reason. And it's also written on the cover here. This came with the cover, so the calculator just slides in like that and protects it, and then of course when it's out, you can flip it over here and put it in this way, just so you don't lose your cover, and it makes it a bit thicker, so it's a little bit easier to hold in your hand. Now if I take it out here, see there it asks for a 6-volt power supply and a 3-volt power supply. Power usage of 0.06 watts. Takes 4 AA batteries and a CR2032 coin cell to keep the memory alive when the AAA batteries are removed. This thing does have volatile memory. If you remove all power, everything will be erased and it'll be reset to the factory settings. And you also get a reset button here, which is marked P. I'm not sure what P is supposed to mean. Maybe it means program or something, I'm not sure. If we take the battery cover off, you get your 4 AAA batteries, which is labeled main, and then the backup battery, which is labeled backup. And you just take out that screw and there's a CR2032 battery. Battery life seems to be pretty good. I've never put new batteries in this thing, but when I first got it, I put batteries in it that were low enough that it gave the low battery message, and I used it for 6 months when it was displaying the low battery message. So I would say battery life is nothing to worry about anyway. But all there is to do now is turn it on. Now, like I said, this has a color LCD display, and it's very unique in how it works. So I'll turn it on here, and you're greeted with a menu here. And that's one of the features that I think makes these things really nice compared to the Texas Instruments calculators. You have a menu-driven interface. The Texas Instruments calculators, when you turn them on, they just boot you straight into the mode where you can enter calculations, and if you want to get into any other mode, you gotta press the function keys and stuff. But here you have a menu. Color LCD display here. This is a very interesting and primitive color LCD display because it can only display 3 colors, red, green, and blue. Now if I go into the contrast setup here, first I'll show how the menu works here. You can see there's a number up to 9, or a letter, A, B, C, D, E, F, by the several modes here in the menu. Just press the key with the little red letter above it to get into a specific mode. So to enter the contrast settings, you'd press E. So I'll just press the cosine button here, and we're into the contrast settings. You can adjust the contrast individually for red, green, or blue, plus the overall contrast if you wish. So let's say I want to make red a little bit darker. There you go, just like that. Now how the display works is very interesting. It works kind of like a grayscale display, in that the different colors are shown simply by altering the contrast of the particular pixels. For example, a light contrast shows up as orange. Now let's say I turn the contrast for orange all the way down. You can see it fades right out. So I'll turn it back up here, and it turns orange and it gets darker to red. Now I can keep turning the contrast up and watch what happens. It turns blue. And I'll turn the contrast up even more. And it turns green. So that's how it works. It's just by altering the contrast of the pictures. A light contrast making it show up orange, a middle contrast making it show up blue, and a very dark contrast making it show up green. And likewise, I can screw around with these. I can make all the colors orange. I can make orange green and blue orange and green blue, or you know, whatever you want. But yeah, how this works is very interesting. Now this color display makes using the calculator very, very nice. First of all, when you're programming, I'll talk about programming this calculator later, you can make text or graphics show up of different colors. Also, when you're actually using the graphing feature of this calculator, you can put multiple graphs on the plot at once and make them different colors to help distinguish them. This was a feature I greatly appreciated when I was using this calculator in school, and I think it's pretty darn awesome. But yes, I totally, absolutely love the color display, and that's really the sole reason why I got this calculator. I wanted a graphing calculator. I had planned on getting a Texas Instruments unit, but then I heard of these calculators, and I read about the menu-driven interface and the color display, and I'm like, wow, I gotta get one of these. By the way, I don't think I've mentioned it yet, I paid $16 for this, so that's pretty great. So we'll go back to the menu here by pressing the menu button, and we'll just go through the modes here. The first mode is run, so we'll press 1. And you're put into the run mode where you can just do calculations. So I'll do 5 times 5 here, and 25. Simple enough. And you can also enter program code on here and it'll run it. And then of course you can press the alpha key and you can enter different letters. And you can store numbers or other stuff in any of the memories here. Every single letter here corresponds to a memory location. So you have the whole alphabet here. So you have basically 26 different places, 26 different memories where you can store stuff. So let's say I wanted to store the number 5 in memory A. I just put 5, press this arrow button here, and put in A. So I'm basically saying 5 goes into A. And now, if I put A, it'll give me the result 5. So that's pretty cool. All the text in the run mode shows up blue. To my knowledge, there's no way to change that setting. So we'll go back to the menu here. Like I said, while the color display does give you some advantages, and I think it's really great, it does have one disadvantage, and that is it can be hard to see in certain lighting situations. Outside is absolutely fine. The more light the better, as a matter of fact. That being said, if you're in a poorly lit area, it can be kind of difficult to see the display. Also, if you're looking at it using a light that is not aiming straight at it, that's not, you know, directly above it, it can make it look a little bit funny. But that being said, I haven't had much problem with it. So moving along here, we have a statistics mode, which I have never used and do not know how to use. You can enter lists of numbers here and then do stuff with them, which is great. Back to the menu. You have a matrix mode. Now, I made great use of this mode. In my linear algebra class, of course, if you've taken a university level linear algebra class, you know that it's all about matrices. And matrices are a very useful tool in mathematics as well. With that being said, this calculator helped me out quite a bit because I would do my homework and, you know, calculating matrices and stuff, and then I'd use this to check my work, which made it really, really great. Now, I can see I have a 10 by 10 matrix here. I don't know if there's anything in it, so I'll press execute, the blue button here, to display it. And here's what it looks like. And you can see the color display at work here. The numbers are blue, and then the lines separating the data from the headers are green, which is really cool. And also, you have these function keys here, which corresponds to these labels on the display, which are also green. So I can scroll through here, see my 10 by 10 matrix, and we can do row operations. We can swap, and then we can do that stuff, which I never had a use for. While I know a good deal of the features this calculator has, I haven't learned everything, so I won't be able to demonstrate everything in this video, but I think everything I do demonstrate would be just about anything, you know, someone my age, a high school or a university level student would want to use this thing for. There's the matricy mode, or I guess matrix mode. I'll make another matrix here, so if I go to an empty matrix, I just start typing in a number. I can give the dimensions, so let's say a 2 by 3 matrix. So there's my 2 by 3 matrix, and I'll just go 1, 2, 3, 4, 5, and instead of putting in 6, I'll put in 2 times 3, which will give me 6. I can demonstrate one of the row operations, which is swap. So if I press row op here and press swap, swap M with row N. So for my M row, well, there's only 2 rows, so I'll put in row 1, and then my N row is row 2, and it should swap the 2 rows, and there you go. And just looking at it now, I'm guessing that the second function here is to multiply a row by a constant. So let's do that. And K times row M gives me a new row M. Okay, that makes sense. So let's say I want to multiply row 2 by 5. So each of the numbers will be multiplied by 5. So my K is going to be 5. Enter. And my row is row 2. Ta-da! And everything's multiplied by 5. So that's simple enough. And then the third function here, K times row M plus row N gives me a new row N. Okay, let's see. Let's say my K value is 2. My M is 1. And my N is 2. So basically it multiplied the first row by a constant, then added that first row to the second row. So yeah, basically, enough of that. Now another cool thing I can do, now let's go back into the matrix mode. Let's go back to matrix A and let's modify it. So we'll delete it first. Yes, so now it's empty. And I'll make it the same, a 2 by 3. There we go. 1, 2, 3, 4, 5, 6. And if I go back into the run mode, I can actually do calculations using these matrices without having to actually go into the matrix mode. So how I do that is, let's see, I gotta remember how to do it. Oh, I think it's Option. Press Option, yeah. Then you press Mat for matrix. And we'll press Mat again. So I'll say matrix A plus matrix B. And it gives me another matrix with both of those matrices added together. So there's matrix stuff. Fourth is a list mode, which again I've never had to use, so can't really demonstrate it here. And then of course the money function of this thing is the graph mode. So if we press 5 for graph, oh look, I actually have some calculations here. I might have actually done these at school. But anyway, I'll delete them. Delete. Delete. So we'll graph something here. We'll go y equals x squared. And we'll graph it. There. So there's y equals x squared. Now let's say I wanted to plot something with it. And then we can show the color display at work. Now, I know it's probably hard to see on camera, but the graph itself is blue and then the axes are green. So we'll make an orange plot here. This one will be y equals 2x. And we press color, and we'll make it orange. And there it is. Now, I'll see if I can bring this into the light here to make it a bit easier to see. Well, I guess that's about as good as you're going to get. Like I said, it's better in real life. We can plot a blue graph with a red graph here, and I can also plot graphs that are green in color as well. So that's pretty great. And in addition to standard graphs, this thing can plot graphs that use polar coordinates as well. So that's pretty cool. So there is the graphing function. Yeah, this is where you can set whether it's, you know, the regular, I forget if it's called Cartesian coordinates or what, but you can have the regular mode. And then the polar coordinates. Man, I really lose a lot of my knowledge on this stuff during the summertime. Yep, there it is anyway. Oh, yeah, I forgot something else. You can also do graphs that are shaded to show you part of a graph that's above a particular y coordinate and stuff like that. So I'll try that. We'll go y greater than. Ah, yes, there we go. Y greater than 2x. And I'll delete this. And I'll make this orange. Ah! There you go. So that's pretty cool, and you have a big blob of orange there on the display. Maybe if I actually made it lighter. Let's make orange a bit lighter. Try that. Yeah, so it's showing all of y equals 2x that's above. Oh, I guess everything that's above the line. So there you go anyhow. So there's the graphing feature. If you're familiar with Texas Instruments calculators, you'll notice that this calculator is kind of slow drawing graphs. These are indeed not as powerful in terms of raw processing power as the TI calculators, but that's nothing I mind. So next is the dynamic graphing function, which I've never had to use, so once again I don't really know what it's for. So we'll just go back to the menu. And next is the table function. You just put in a regular function, and then it gives you a table of the coordinates. So that's pretty cool. Back to the menu, we have recursive functions, which I've never had to use, so can't really show that. There's the conics function, which I've never used, but I know kind of what it does. You just lets you draw, you know, sideways parabolas and circles and stuff. So draw a circle here. Oh, okay, you put in values such as the radius, and I don't know what h and k are, but I'll try 5 and 10. And let's press draw. And I need to change my window a bit. So once that's done, you get a little indicator at the top right when it's working, and you can't do anything while it's doing that. So I'll just go -10 and 10. Try again. Ah, there we go. Oh, it's quite a big circle. Actually, it's an oval, it looks like. Let's try h equals 0. Let's see, I did k equals 0. Okay, I think that makes it a perfect circle. Oh no, still an oval. Oh, I see why it's an oval. It's because the display is, wider than it is tall, so it's going to be stretched out a bit. But, yeah, anyway, I've never had to use that, so I don't know all the ins and outs of it. Just while I think of it, the display resolution is 128 by 64 pixels, which is actually slightly more than Texas Instruments calculators, which are 96 by 64 pixels. Our next function is one which I've used quite a lot, the equation function, so we'll press A here. And we'll press, I've never had to use simultaneous or solver, but I have used the polynomial, so we'll press F2. And degree, I'll go to the second degree. And basically you can put your A, B, and C values of a quadratic function in. I see I already have one here. I'll change this value to 9. And you can solve it for the x-intercepts, which in this case are those. So that's pretty cool. So that's all I really know about that function. Next is the programming function, another big one for graphing calculators. This thing is unable to be programmed like Texas Instruments calculators can be programmed. Texas Instruments units can be programmed in assembly language in addition to the Texas Instruments BASIC. This cannot be programmed in assembly language. It has the Casio BASIC in it. So we'll press B, and I already have some programs here, some of which I've made, and then some of which I've loaded from the built-in library of this calculator. So this first program here is called Move 0, and I cannot get it to work. I did get it to work once, and then I modified something and it didn't work, so I changed it back and it still didn't work, and it's never worked since. 204 bytes in size. I'll show you the code. This is what the code looks like. This is just something I copied from a website, and I typed it in myself. Typing in a program like this is quite a lengthy process on something like this. But we'll go back here and I'll run it and it'll just crash. Gives you that syntax error. But how it's supposed to work is you just have a blinking O here, and you can press the arrow keys and move it around. The next program, Tex, is one that does work because it's not nearly as complicated. 63 bytes in size. All it does is it asks you for two numbers and then it multiplies and gives you the answer. So I'll run it here. First number 5, second number 6. Oh, that doesn't work right either. Well, normally it would say display and then it would say 30, but I see I've modified this as well. That's kind of dumb. Don't know what I did wrong with that. Third program here is another one I wrote myself, 74 bytes in size. All it does is display text on the screen of the three different display colors, so I'll execute it here. And some of you might recognize what that phrase is from, but there you can see it's in the three different colors. So that's pretty cool. Row Red A. This is one that comes from the software library and was one I made good use of in school. It takes the matrix that is stored in memory location A and it row reduces it. And if you don't know what row reduction is, you'll learn it if you ever take a linear algebra class in university. Actually, if you're American, you might actually learn that stuff in high school because your high school education is superior to ours. Basically, row reduction, it just basically it makes all the numbers in a matrix as small as possible while still retaining all of the mathematical information that the matrix needs to be itself. And matrix row reduction is, it has a ton of mathematical uses and real-world uses. It's used in stuff like data compression and stuff, and it's very useful, and I found it quite interesting. I liked row reducing matrices. It's quite a process to do it by hand. This thing does it very fast, but it allowed me to check my work, and I found it very interesting. Now, we currently have a matrix stored in A, so I'll go ahead and execute this. And there it goes, and our matrix that was like, what was it? It was like 4, 5, 6, 13, 20 something, and it managed to reduce it down to 1, 0, -1, 0, 1, 2. So there you go. I don't think I remember how to row reduce matrices anymore. That's too bad. I'll have to look at one of my linear algebra tests, and that'll probably help me out a bit. Although I may not ever have to do it again, I don't know. But anyhow, there's the programming. And then this program here is a Fibonacci generator, which I don't think I know how to do very good. I just put random numbers and it doesn't seem to do anything. Yeah, I don't know what it's doing here. So I'll get out of that. And I'll show you the software library. If we go and press load here, and you can actually choose software titles based on different countries. I don't know what that's all about, because I would think they'd all be useful. But we'll go to USA here, and you have different stuff that I imagine is prime. That's a program that tells you whether a number is prime or not. So if I press execute, it loads it into memory, because all these programs, they're not in memory, they're stored in ROM. So we'll go back, and there's prime, so we'll execute that. Is number prime? Enter a number. Number is composite. It is divisible by 3, so it's not a prime number. Try it again. I'll put in 3. Number is prime. So that's pretty simple. Anyway, really cool things you can do with a calculator like this. TVN, that's some sort of financial thing, which I've never learned to use anything from it. Link, that allows you to connect this thing to a computer. That's something I haven't mentioned yet. On the bottom of this calculator is a little communications port, which I know has never been used because the protective rubber plug is still in it. And I don't plan on taking it out since I don't have the cable for this. But you could get a serial cable for these to hook them up to the serial port of a computer, and you could use it to transfer programs to and from the memory of this calculator. And that made it very useful for loading programs, because you could type the programs on the computer and then load them here instead of having to type them on this funny keyboard. There's that anyhow. Don't think it'll do anything. Then the contrast, which I've shown you, and the memory. So we can look at how much memory we've used of the calculator. So programming memory, 880 bytes, no memory used in statistics, 240 bytes in the matrix mode, 20 in the list file, 10 in the graphing mode. So there's that. Now if I go back here, of course you can reset it. I won't demonstrate that. And really, that's about all there is to show of the Casio CFX-9850GB Plus color display graphing calculator from 2002. I think these are really great. Like I said, they're not as powerful, and these actually aren't as feature-filled as the Texas Instruments graphing calculators. However, I think the menu-driven interface, which is on most of Casio's graphing calculators, make them very easy to use and much more accessible than Texas Instruments units. And I think the color display is pretty cool. And I think it's too bad that Casio doesn't make these anymore. Like I said, they discontinued them in 2008. If you want one of these, you will pay at the very lowest $10 for a fully working unit. Like I said, I paid $16 for this. You'll pay as much as $75 for one that's new in the package, although that's quite rare. You can usually find them new in the package for as little as $40 or $50. And they're quite plentiful on eBay. As for the particular model, the GB Plus model, like mine, is definitely the most sought after model because it has the software library. The GC Plus model has, of course, 64 kilobytes of memory. So if you want to store a lot of programs, that's definitely the model to get if you can live with the modernized style of the casing. And then as for the original model, the 9850G, and the model after that, the 9850GA, they don't have either of those things. They just have 32 kilobytes of memory, and they don't have the software library, but I think they're good calculators nonetheless. As far as I know, the GA Plus just fixed some bugs in the G model. But regardless of the model, I think this is a pretty great calculator. Now, I have a little fun game for anyone who's watching this video. Just today, actually, I bought something on eBay that I have been looking for years. It's an electronic device that's quite rare. Whenever it comes up, it seems to go for really wacky prices. Well, finally, after like 2 or 3 years that I've been looking for one, I won one today, and I won it for a good price. Now the game is, the thing I bought on eBay today, which I'll be reviewing when it gets here, uses the same type of display as this is. Now the challenge is, try and guess what I bought. Like I said, it's a consumer electronic device, and it has a display just like this. Not necessarily the same shape or size, but it's a color display that uses the same technology. See if you can guess correctly. Whoever does guess correctly wins a metaphorical cookie. So, there you go. I hope you guys enjoyed, and I will see you guys next time.